Good afternoon, my name is Devon Davis, and today I'll be explaining some math problems for you in terms for a marine engineer. Okay, so first of all, I'm starting off with a Pythagorean, and basically, if you were to relate this to marine engineering, I guess you could say, if you had two sides and you're missing one of a piece of steel that you were having to put into place and you weren't sure the measurement of it, you'd use the Pythagorean theorem to find it. So let's say we're cutting this piece of steel and we know two sides but we don't know the third side. We could use the Pythagorean theorem, and I've already gone ahead and filled it in and showed the Pythagorean theorem. A squared plus b squared equals c squared. A squared is 8 squared and b squared is 8 squared equals c squared. So we're trying to find c squared. So I've already solved it, but I'll explain it to you as I go along. So what I've done is I've squared 8 on both sides and then added it together, which got me, hold on, 8 squared on both of these 8 squareds are equal to 64p, so then I added those together, give me 128. And then to solve for c, you actually have to square root it. And that would actually solve for the missing side, which is 11.31. So that's your answer for the first one. I'm assuming the most common misconception is that most people, when they get 128 equals c squared or whatever number they have, they forget to square root and actually solve their answer. That was the same problem I had doing these. Okay, so here's my second Pythagorean problem. Same setup, just a few different variables. B now is 4.5 and A is 5. So I've already plugged those in over here. If you can see those. So see, A is 5 squared, B is 4.5, C is C squared. And you're trying to find C squared again, the missing side. So squared 5, 25, 4.5 squared, 20.25. All you have to do then is add those two together and then square root it, which is what I've done down here. And your final answer is when you plug that into the calculator, you get 6.72. So that would be your missing side for C. Again, you can relate this to cutting a piece of sheet metal where you know a couple of the dimensions, where you're trying to fit it into a weird spot and you're not really sure how long it's supposed to be, or you can't really measure it. So that's all the Pythagorean problems. Okay, so here I did an angle of elevation problem, and I set it up basically like there's a guy on a ship and he wants to put a little walkway from the ship to the dock. So he has to find the angle from the ship to the dock, and he knows that it has to be 60 feet high, and he knows the degrees, but he doesn't know how long it's going to be. So I'll show you how I solve that. So if you look at it, it resembles a triangle, just like we did in earlier chapters. And basically, you're looking for the... Well, if you look at SOHCAHTOA, it's definitely TOA because opposite over adjacent, and there's your opposite and there's your adjacent. So in order to find the opposite, you have to use tangent. So I've already set up the equation right here where I use tangent of 12 degrees equals 60 over x, and 60 is just your height. And then basically all you do is you switch tangent with x, and then you solve. So you punch in on your calculator 60 divided by tangent of 12, which is your angle. And that will give you your x, or your missing side. And I got 282.77. Now, one one of the most common problems associated with this is that people have it in radians on their calculators, and they can't get the right, the right length because they have it wrong. So just make sure you watch out for that. That was the same problem I had, coincidentally. So, make sure you pay attention to your calculator. So this is the last angle of elevation problem that I have. And I basically set it up just like, I don't know, you're trying to find the height of a building. So that would kind of relate to engineering, or either a building or an engine or something sort of like that. Or even the height of a ship, So I've already gone ahead and set it up just like I did before. And it's a very similar question because you already have the height, which is 25. You already have the angle, which is 45. And you're still trying to find the opposite over the adjacent, which is TOA, in SOHCAHTOA. The x being the adjacent. So I put all those in, and again, we swap tangent of 45 for the x, and then we solve it on the calculator, which it's going to look like that, and then that would give you your x of 25. But let's just go ahead and do that on the calculator just to make sure everything's okay. So we'll put in 25 divided by tangent of 45, which is our angle of elevation. That gives us 25, so it checks out. And again, make sure it's in degrees and not radians. Okay, so this problem is a area problem. I'm going to do both an area and a perimeter problem separately. I'll count them as two. I wasn't really sure exactly how you wanted us to set that up, but anyway. So here's my area problem. Here's my area triangle. It's got all of the parts labeled. The big letters, obviously, they're the angles, and the small letters are just the sides. So you're trying to find the the inside area of this triangle. So here's the equation that we're going to use. All you do is you just plug in your sides and your angle, which B is your angle, and AC, those are your two sides. So you plug those in, and this is what you get. So area equals 1/2 12 times 13 and sine of 45. And of course I've already solved it, but you still have to do it on the calculator, which is a little bit easier than writing it all out. So let's do it on here. So 12 times 13. Okay, multiply that by 0.5, which is your half. It gives you 78. And then you do 78 times sine of 45. So 78 sine 45. It gives you 55.154, which is exactly what we got right here. So as far as problems and issues go, I know I've said this a few times on a couple of the other ones, but again, you need to make sure it's in degrees on your calculator. Make sure you have just make sure you put the correct information in. You don't grab the wrong piece of information from here, like use B and put it blank and just solve it for one. You need both sides. So yep. Well, now we'll do a perimeter problem. Okay, so here's our last problem. This is a perimeter problem. We used a trapezoid for this one, and it's a little more confusing than just finding the area of the inside, because you have to. It's a different equation. It's just seems a bit strange, but it's not very complicated. So here's all your sides and your height and everything and length. And 12 is actually the overall length of the bottom, but 4 is just the length of that one section for that little slice of triangle. So I made up an equation right here. So height, which is right there, plus x, which is the length of that triangle on the end of the shape there, equals perimeter squared. So I went ahead and put the whole equation together. So height, obviously 4.77 squared, plus 4, which is right here, see? And equals x squared, or perimeter. I did forget to mention to square these, but, you know. Then I went ahead and I've already solved it, so it's 6.22, but again, let's just check that on the calculator. So 4.77 squared plus 4 squared, which is, again, right here, equals 38.75. So then, because that's square rooted, you actually, because that's squared, you actually have to square root whatever you get between 4.77 and 4 squared. So 38.75 is what we square root. So 38.75, and enter, is 6.22. And 6.22. And as far as relating this to the engineering world, or even sailing, I suppose, most of the equations I picked, I would find helpful in the construction field because I've been a welder before. So there was times where we had to cut out a piece of metal and we weren't particularly sure of the length of a side or an angle or anything. So all the equations and everything that I picked here, all stuff that would mainly pertain to welding, but I suppose you could relate it to engineering, which, you know, I don't know, it seems more appropriate to relate it to here than there. But as you see, I've got all these covered. And as far as the issues, like I said, make sure you have everything correct. Like where I forgot to square it in the equation, you have to square it in here, you know. So make sure you have everything in order. Make sure you have it in degrees, not radians, because that's messed me up before. And that should do it.